Well, what I feel that the word, the quench or the quenching, it's a very primitive word. It's not. It's nothing related with the technology. It's basically the human word, the quench, because the first thing you might have heard about a thirsty crow story in your childhood and your father's childhood, your forefather's childhood, that there was a crow and he was a thirsty and he wanted to quench his thirst. So basically, I think maybe around 500 years back or something like that, when this word of the quenching had come, it must be related only with the human being. That is that you wanted to quench your thirst, and because of that only it has come. And this particular word might have been incorporated into the technology because all the technology have been evolved with the human resources, and possibly that could be one of the reasons why this has been this thing. And before I go for the talk, let me clarify with you that this particular talk was prepared by Mr. P.K. Deval, but unfortunately he was not here, and I was ordered by the chairman of the chapter that I have to take this lecture, so I am here. So in case I am not able to do the justice with the talk, please do not blame to me, because I am not well prepared for this particular talk as on today. Okay, next please. Today I am just, as you might have gone through that the various processes of the heat treatment, then you have got the furnaces. Now the next thing is coming, that whatever the process you want to do it, after that, that equipment is being employed to get this process, which is called the quenching processes. And first of all, there is a small history maybe for the quenching, that how it started, and this was the first thing which I told, that how it has, the quenching word has arrived and how it from it has come. Then second, the type of the quenchant, that what are the type of the quenchants developed in due course of the time. Then why we have to select the various quenchant, that what will be particular better for your products, that what the result you want to achieve. Then we will go for the advantages and limitations and the application of the each type of the quenchants, that particular which quenchant you have to apply for what purpose and what are the properties you are looking for. Then the cooling characteristic of the quenchants, that how fast it is getting cooled. And meanwhile, I welcome Mr. Sandeep Parikh, who is our secretary for the chapter. So then the quenching system design and consideration, that what will be the optimum consideration for the design, that what we will get out of that. So the better results and the desired results are to be obtained out of that. And then the maintenance of the quenchant, that how we have to maintain your quenchant. So whatever the things you are looking after your process, that the results are being obtained. And then how do you go for, suppose whatever the problems you are facing, that how those problems have to overcome. Next please. See, as I told you, in fact I told you only for your forefathers, but it has gone beyond Darwin's forefathers also. Like 3,500 years back, the people are knowing about that. First of all, हम पानी पीने के लिए, I mean, we want to thirst. So the water is the basic quenchant what was available in the ancient time. And later on, so many, as development took place, as the evolution took place, things have been developed like that only. So we have been employed this old practice, and for that one we have taken the advantage in the agriculture, industry and wars. And the first early quenchants, as I told you, that is the water, and after that the oil and vegetable oil, fish oil, and then later on, as the science and technology progressed, we had the various other quenchants which have been developed in due course of the time. Now first of all, as I told you, the water, this is the natural quenchant, and I think Kajaria has talked about the air quenchant also, which is the art, I mean this is the natural process of quenchant is the air, because for air you need not to employ, just you heat the product and keep it there, it will be automatically getting quenched after some time. So the air is the natural this quenchant, and then the water is the, though it is available naturally, but it has to be employed for getting the quenchant results. Then the solutions, various solutions are there, like the caustic solutions. Then we have to, suppose you are using the water as a quenchant, then suppose some of the additives you are adding, then it gets the better result or the desired result. So the various quenching additives are available. Then various oils are there, which are called the quenching oils. Then the polymer quenchants are there. Then molten salt bath is there. These are the various molten metal bath is there. Gases are there. Then fog quenchants are there. the various these things are there. It's okay. Then we go for the performance wise, that suppose we want to have the good result, whatever the material you are processing for the heat treatment, and you require certain quality after the heat treatment. So the desired result will be obtained once you have the performance of the various quenchants. Like the first criteria for that one, that is to be achievement of desired property, metallurgical and dimensional. It should not happen that the moment you quench your product and it changes metallurgical proposition. Whatever the inherent properties of the materials are there, that has to be maintained during the quenching time. Simultaneously, there should not be any dimensional change. Within the permissible limits, it's okay. Suppose you want that your permissible limits are like say 10 micron, 20 microns or something like that. Beyond that, there should no distortion, there should be no any dimensional change in that one. So that has to be the first criteria for that. And then the finish. The important thing is that whatever the finish, it has been before. Suppose it's a machine finish, after the quenching, your machine finish should be available to you, that whatever the finish you want, it should be available after the quenching process also. And simultaneously the life also should be increased, because it should not happen that after the quenching you expect that life should be of the product over 10 years and it work only for 2 years or something like that. So these are the various performance quenchant criteria are there. Like that then less drag out or the consumption cost. It should not happen that we're using the quenchant, the material is of 100 rupees kg, and after the doing the quenching process, it costs 500 kg or something like that. So it has to be cost effective also. Then absence of the quench cracks. It is the simultaneously it is coming with the surface finish also, that there should not be any surface distortion or any surface problem in that one. Then reduce rework or the rejection cost. It should not happen that again and again you are doing the quenching and you are not getting the desired result. So the rejection takes place. And secondly, when you are doing for the rectification, the cost addition is there. So this should not happen. And then optimum cycle time. You are looking for the time, because it's whatever the results you want, you should be getting those results with the optimum time or with the minimum time. So the maximum output you can take out of that. And the next is that the no fire hazards. It should not be having any it should not create much of the pollution. It should be human friendly. It should be if it is any organic salt is there in that one or organic solvent is there, then you have got always the time or always the possibility is there that you can have some fire. So it has to be environmental friendly sort of the thing. Then the post quenching cleaning. And when you are doing after the quenching is being done, it should be very easily you should be able to clean. So whatever the things you described on top, that metallurgical and dimensionally there should not be any change. Longer life should be achieved. Simultaneously, the moment you clean it, it look like that original product you have got it. So these are the various performance you are looking for the quenchings. Then we have got the advantage, limitations, and the application of the different type of quenchants. Please. First is water. As I told you, this is the first quenchant, what was applicable and what was available with us. So people tried with the water only. Ample of the water is available, whole of the world. 3/4 of the world is of the water. So there is absolutely no problem, because it's totally economical. There's no maintenance required, that you have to purify the water or something like that. Once you use it and throw it away, the next bucket you can use it. Then the high quenching servability is there, because whatever the amount of the water you want, you can make it. But there is certain limitations are there, because water, though it is a natural quenchant available with us, but it has got certain limitations. That is why the new development and new advantages and new technologies for the quenching have been evolved. Like it's cracking and distortion. The moment you might have seen at your home also, sometime if your tawa where you make your rotis, if it is very hot and you put some water in that one, it makes a very sound is there, and then that particular place, till the time you get it very clean, it's always some white spot is coming. So these are the various limitations are there in that one, that it's cracking and distortion, because that is a very thick this thing, that is why it's not getting distorted. But had it been say wrote 1 mm or 2 mm, possibly it will get bent or it will crack or something like that. Then the soft spotting, that spotting is incoming, that one I told you that. Not suitable for high hardenability material. And suppose you want to quench it more than EN9 series, where the hardness is around more than 60 RC or something like that. For that particular quality of the desired result, water may not be suitable for you. The common application for the water may be the quenching of the water, low hardened material, like up to EN8, you can do the quenching with the water quenching. Then the solution annealing of the aesthetic steel, stainless steel, you can do it with the water. Then solution annealing of the aluminum alloy, you can do it. But you can be restricted only to this type of the alloys or this type of the stainless steel or this type of the carbon steel, not beyond that. Please next. Then various quenching oils which are available, they have got the better advantages than the water quenching, because it has also got the low maintenance as per the water one. Low quench severity is also good, then consistent result and less distortion. This is the advantage as far as the water is concerned. If you compare with the water, that here you will find that the distortion is taking place during the water quenching, whereas here the distortion is very limited. But still this has got a very limitations for that one, because once the oil is heated beyond its fire point, then it becomes little fire hazardous, because it can catch the fire at any time. So we have to be very careful while making the oil as a quenching. Then oily fumes in the shop floor, I mean the pollution, it creates a lot of pollution out of that. Difficult to clean and high consumption. See, once the oily surface is there, it becomes really difficult to clean it, unless you have got some caustic or something like that. You have to apply another chemical media to get it cleaned up. So these are the various limitations for using the quenching oil. And the common application for this one is the quenching of the alloy steel, die steel, tool steel, martensitic stainless steel. Then quenching where the dimensional accuracy is important, because these are the very costly steel or the special type of the steel. So you have to be very careful, because if you are using the water quenching, then there could be some dimensional variation, whereas if you are using the oil quenching, then there could be you can avoid those things. The next is polymer quenching. After water and oil, there are very friends, after that, when we got water and oil, then there were certain other things were there. Whatever the results you wanted to obtain after using the water or oil, you were not able to achieve those qualities. Then people thought of it, like you people, you are working the shop floor, educated people, because every time you go for the innovations. So these are the various innovations after that, what other material we can be used, so you can get the desired results. That was the polymer quenching. It's a flexible quenching capability. It is also cost economical, but not as far as compared to the water and the oil. Operation and environmental friendly. When you are using the polymer quenching, it doesn't smell much. It doesn't give the fumes as the oil is giving, and it is not fire hazardous also, because the temperature of the polymers is very high as compared to the oil. So these are the various advantages, but still it has got the limitation. That is extremely sensitive to the common applications, means it cannot be used for the common applications, because polymer, it can react with something also. So it has to be used only for the specific purpose. For any purpose you cannot use it. Then can change variety of the material and application. Solution annealing of the aircraft body parts, that's what I told you. That this has to be used only for the very specific purpose components, like aircraft or very high quality material, only this has to be used. Automotive forgings, induction hardening, where the special applications or the metallurgical applications are to be employed, there the polymer quenchants are used.